Hi, and welcome to Scholars Forum. Today we will be looking at binomial expansion, one of the very core courses in mathematics. Alright, so the word binomial expansion has two things inside there, binomial and expansion. So how do we expand and how do we use binomial for expansion is what we're looking at today. Alright, so binomial expansion. Alright, so take for instance, you have something like this, x plus y to the power of 3. Traditionally, we would want to do this, x plus y into x plus y into x plus y, correct? This is the method we are very, very familiar with. But in this case, we have two methods under the binomial expansion that we can actually use to expand this and still have the same answer as the answer from traditional method. Now, these two methods are what we call the Pascal's triangle and the binomial theorem. Under the Pascal's triangle, this was a triangle created to actually notify and grab the coefficients of each term in the expansion. Now, for every single term or for every single value that you get in your expansion, we call each one of them terms. All right. So for this, if you were to expand this completely, all right, so hold on for a minute, we'll get back to this. Now, if you were to expand this, officially you'll be getting x times x at first, going these two ways. For instance, let's move this away from here. So I can just explain what terms are. X times x, x squared, and x times y, xy, and y times x, still xy, and y times y, y squared. So at the end you have x squared plus 2xy plus y squared. Now what we call a term is each of these things that are here. Alright, so x squared is first term, alright, 2xy is the second term, alright, and then y cubed is the third term. So it applies in binomial expansion also. So now let's take a standard question and look at what Pascal's triangle is actually telling us to do. Now when we get to Pascal's triangle, now in getting to Pascal's triangle said that if we are to run an x plus y to the power of 0, so far in mathematics, whatever is raised to the power of 0 gives 1. That means the only term we'll be having is 1. Now follow me there. Let me align this. 1. Now if I have an x plus y to the power of 1, x plus y to the power of 2, x plus y to the power of 3, x plus y to the power of 4, I'll stop here and give you the privilege to do yours from 5 down. Alright, now from this part to this part, x plus y to the power of 1, according to Pascal's triangle, what it tells you, or the algorithm, the very simple algorithm for it, is to look at your left hand side and the right hand side. What exactly is on the left hand side of the previous work, or of the previous exponential? Now the previous exponential was 0, now the current exponential is 1. So what you do is 1 to your left, there is nothing here, so it repeats a 1. 1 to your right, there is nothing here, it repeats a 1. Now that's the coefficient 4, an expansion of x plus y to the power of 1. Now when you move to the next exponential, to the power of 2, the same method applies. This time around, what do we have to the next? Nothing here, 1. What do we have next to it? Another 1. So 1 plus 1 gives us a 2. When we can look at this one, 1 to the next, there's nothing here, so we repeat the 1. Now when we go further to the power of 3, what happens is still the same thing. 1 to the left, there is nothing here. 1 to the right, there's a 2. So 1 plus a 2 gives you a 3. Okay, now we're done with 1. Now to 2. 2 to the right gives you a 1 also. 2 plus 1 is still 3. Alright, we're done with 2. Now to the left, 1. 1 to the right gives you nothing on the edge. So it gives you just 1 repeated here. Now to the power of 4 finally. Raised to the left, okay, it's the same thing. 1 to the right is 3, 1 plus 3, that gives you 4. 3 plus 3, that gives you 6. 3 plus 1, that gives you 4. And 1 plus nothing at the edge gives you 1. I believe you've gotten the algorithm and the method already. Now this is what we do in Pascal's triangle. Now this is why it is called a triangle. Now when you connect the vertices, alright, when you connect each of these vertices to themselves, okay, now let's go here, 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 yes, then here and here, then here and here and here and here, and here. Yes. Now, looking at what you have here, we just form the triangle, okay? And this diagram from here, if I put dotted lines like this, okay, and I put that, we follow that line up, and I put dotted lines all the way down. We just formed a triangle, okay? So this is what we call the Pascal's triangle. Are we good? Alright, now moving from this edge, what this means is that if I'm to expand x plus y to the power of 2, when I am done expanding and getting all of my terms, each of the terms will have a coefficient of 1, 2, and 1. We should take a practical example. Take for instance, we are doing 2x plus y to the power of 3, and we've been told to expand using Pascal's triangle. How do we run this? Now, what we do simply is to expand initially the whole of this. Now let's study the algorithm together. It's actually simple but complex, and actually complex but simple. Okay? So 2x at first, the power you have is a 3. Okay? Now the power you have is very, very, very important. The power you have at the top determines how many terms you are going to have. If you have if you have the power of 3, you're going to be having 4 terms. If you have the power of 5, you're going to be having 6 terms. If you have the power of 7, you're going to be having 8 terms. So at the end of the day, the power of 3, you're going to be having 4 terms. Now, how do we know that we're going to have 4 terms? I don't know. But that was what Pascal's triangle said. Alright? And at the end of the day, after solving, you'll finally see that you actually have 4 terms in play. Okay, so now the first term is this. Now we take this part to be A. We take this part to be B. Now this is how the thing goes. We take your A to the power you have on the outside. Now your A is what? 2x to the power of what? 3. Now, y does not have anything to take, alright? Because it's taking the whole 3. So y has a 0 here. Now, the next term you are going to, the first thing you did was to give the whole power to A. This time around, you'll be reducing the power of A by 1 and increasing the power of B by 1. Okay? So at this point, I'll be having 2x to the power of 2 and y to the power of 1. Now the next one, it repeats like that until 2x, okay, gets the same power as y for the beginning, which is 0, okay? So that means we keep dropping 2x, 1, y will increase again to 2, 2x, 0, and y will finally become 3. So this is the logic behind it. When you start, your A carries all the power and your B starts with nothing. When you end, your A that started with all the power ends up with nothing, and your B that started with just one power ends up with all of the power at the end of the day. Now, this is not the final answer, okay? Now, this is just the expansion terms, alright? We will still get to the coefficients. I think we not bust your head too much. Let's just continue with this. Now, 2x to the power of 3, 2 in 3 places gives you 8 here. X in 3 places, which is simple algebra, that gives you x cubed, okay? Multiplied by, wherever you see me put a dot, that means multiplication, alright? To make the work kind of clean, alright? Now, 8x multiplied by y is the power of 0. As we know, in mathematics, anything to the power of 0 is 1, okay? Then plus 2 to the power of 2, 4, x to the power of 2, x squared, multiplied by y to the power of 1, y, plus 2 to the power of 1 is 2, x to the power of 1 is x, multiplied by y to the power of 2, y squared, plus 2 to the power of 0 is 1, multiplied by x to the power of 0, 1, multiplied by 1 to the power of 3, y cubed. So your expansion terms will be 8x cubed, follow me now, 8x cubed multiplied by 1, 8x cubed, plus 4x squared y, okay, 4x squared y, plus 2xy squared, 2xy squared, plus 1 times 1 is 1 times y cubed. So at the end of the day, y cubed. Now, these are your expansion terms. This is not the final work. The final work is when you now return back to your Pascal's triangle, okay? The Pascal's triangle said that when you are expanding to the power of 3, what are the coefficients? The power of 3, 1, 3, 3, 1. Now, this is for the first term, second term, third term, and fourth term. So that means I come to this place now. This is my first term, so to carry the coefficient 1. So I carry 1 into the power of 8x cubed plus my second term is a 3. Alright, the coefficient for second term is 3 into 4x squared y. Third coefficient is a 3 again into 2xy squared. And fourth coefficient is a 1 into y cubed. So at the end of the day, my final expansion is 8x cubed plus 3 times 4, 12, x squared y plus 3 times 2, 6xy squared plus 1 times y cubed. So this is your final expansion. Now, like we said in the beginning, when you have a power of 3, you have 4 terms. As you can see, we expanded 2x plus y to the power of 3, and we ended up having 8x cubed plus 12x squared plus 6xy squared plus y cubed. 4 terms. Now, this is how we apply Pascal's triangle to solutions of binomial expansions. Now, in the same way, we could also show how we use the binomial theorem for this case. Now, in the binomial theorem, if you don't have a knowledge of permutation and combination, you might be finding that place a little bit difficult, but then we'll do a fast review on what permutation and combination is, so that in your own leisure time, you can develop on it. All right, now let's use, since we're done using the Pascal's triangle here, let's try create space for the binomial expansion. All right. Okay. I think I'm going to have to use here. It should be enough for us. Okay. Now for binomial expansion, there's a rule that follows it, n combination R. Please follow me. Now the binomial theorem is based on a complete formula. Okay, now the formula goes like this for every single term. All right, the term looks like this: n combination R, okay, of a of x, all right, to the power of n into bracket b of y to the power of r. Okay, now the next term, just like how we did on that edge there, where the a part reduces power and the b part increases power, what we would simply do is n combination R, okay? This time around it will be n minus 1. It will be n combination R minus 1 into ax to the power of n minus 1 into by to the power of r plus 1. Okay? Now r plus 1, sorry. Alright, now this is how the method goes. The formula itself might actually be tedious enough for you to put in your head, but then this is how the principle works. Let's go straight to an example like the one we have on the board, 2x plus y to the power of 3. Now this time around we'll be solving with binomial theorem. Now this is how it starts. Now what is my n and what is my r? That's the first thing you think of. Now your n is a power on the outside, the exponential you're working with, which is a 3. Combination. Your r always starts at 0. R is always starting at 0. So now we have a 3 combination 0, okay, of what's our a? Our a is 2x. The power of, what is your n? Your n is 3. Combination, what is your r? Your r is 0. Plus, the next one, so we should do what? 3 combination r plus 1. 3 combination r is 0. 0 plus 1, 1. Into bracket 2x, n minus 1 becomes what? 2. Okay? Then r plus 1, which is of course we have here already, is what? 1. So that will be y to the power of 1. Plus, now this is how we keep incrementing until we get to the final 10. Alright, so I will quickly write that up into 2x, 1, y squared plus 3 combination 3 into 2x, 1, y cube. Now, someone I want to ask how you get to know where to stop, or how you get to know that the binomial theorem for that particular question is done. When you get to the point where your n equal to your r, automatically you are ending there. So if you are starting with an n being 6 and your r becomes 6, that is where the last term is. You cannot do a 6 combination 7. It is not possible. You can't combine a higher number against a lower number. Okay? So now from this part, how do you now run the problem of 3 combination 0? For as many of us who are not familiar with permutation and combination, for as many of us who do further maths from junior school or high school. Okay? Now let's quickly do a fast recap. Now where do we put that fast recap now? Let's check for the space somewhere here. Now let's look at this here. Now if we have an n combination r, okay, the formula is given as n factorial into n minus r factorial Now, for as many who might be looking and asking, what's the meaning of factorial? What factorial? Like factors of numbers? No, not factors of numbers. Actually, you've learned too much of prime numbers and odd numbers. In this case, factorial is something different. Factorial means from the start of the number you have to the very ending of that number. Okay. Now, for this one that we have here, 3 combination 0. Now, your n is 3, your r is 0. So your 3 factorial over n minus r, 3 minus 0, that still gives you 3 factorial. Your r is 0 factorial, 0 factorial. Okay? So this will be 3 factorial means 3 times 2 times 1 over 3 factorial is still 3 times 2 times 1. Multiplied by 0 factorial. Now in mathematics, 0 factorial is not 0, 0 factorial is 1. Okay, so whenever you see 0 factorial, it is 1. Multiplied by 1. Now you will agree with me that what we have above and what we have below is the same thing. Because after multiplying 3 times 2 times 1, we get 6. Times 1 again is still 6. When we go to the top side, 3 times 2, 6 times 1, 6. So 6, we cancel 6 and give us 1. So that means 3 combination 0 is 1. So we come all the way down here and we write 1 multiplied by. Okay? 1 multiplied by, now 2x cubed. Now, remember we've done this from this part before. We could simply bring in the answer from that edge. Okay? Now, the only difference we are going to be doing here is the fact that we are going to be calculating by 3 combination 0, 3 combination 1, 3 combination 2, and 3 combination 3. Aside from that, every other thing we have done so far. Now, here is only 1, here is 0. Yes, for the correction. So, whatever we have here is still going to be the same as what we have at the first work over there. So at the end of the day, 2x cubed y0, taking it to this side again, 2x cubed y0. So what do we have here? 8x cubed. Alright? So we can bring in the 8x cubed on this edge to save time. Alright? 8x cubed, okay, plus 3 combination 1. Now let's go back to our combination and change this now to 1. So that means we'll be doing 3 factorial over n minus r becomes 3 minus 1, which becomes what? 2 factorial. Okay? Then what is your r? R factorial becomes 1 factorial. Now 1 factorial is still 1. Okay? 0 factorial 1. 1 factorial 1. Okay? Now this edge, we can clean this off. Or better still, right on the side. So 3 factorial is still 3 times 2 times 1 over 2 factorial 2 times 1 multiplied by 1 factorial 1. So at the end of the day, you will agree with me that 2 times 1, we cancel 2 times 1, remaining 3 over 1, which is 3. So that means we'll be having 3 multiplied by, now what result did we get for 2x to the power of 2, y to the power of 1? Let's trace that place back again now. 2x to the power of 2, y to the power of 1. We got 4x squared y. So on 4x squared y, we bring that to 4x squared y plus 3 combination 2 now. So we come back here again, changing your r to 2 this time around. This becomes something different. N minus r, 3 minus 2, 1 factorial into r, 2 factorial. So at the end of the day, we'll be having 3 factorial, which is 3 times 2 times 1 over 1 factorial, 2 factorial, which is 1 times 2 times 1. If you're clear with this now. So 2 times 1, we still remove 2 times 1, remaining 3 at the top. So we still have 3 in brackets. What do we have for 2x power of 1? The whole of 2x power of 1. 2 in one place is still 2. Okay, x in one place is x. And y in 2 places is y squared. Okay, then plus 3 combination 3. Now I will give an expo on what this and what this can actually do for you. And for the fact that it's a 3 combination stuff, we will come back to very fast techniques that you can use to maneuver these methods in case you do not have a calculator with you at the point or at the moment. Now for 3 combination 3, we go ahead to change this part alone. So here becomes 3. Alright. Then n minus r becomes 0 because that will be 3 minus 3, which is 0 factorial, into r now is 3 factorial. Now you will agree with me that 0 factorial is 1, which is here already, and 3 factorial is going to be changing to 3 times 2 times 1. So the whole of this cancels all of that, so that means there's just 1 over 1, which is what? 1. So at the end we have 1 multiplying 2x to the power of 0, everything here becomes 1. Then multiply by y cubed, Okay, so finally at the end of the day, 1 multiplied by 8 is still going to give you 8x cubed. Alright, plus 3 multiplied by 4 gives you a 12x squared y, plus 3 multiplied by 2 as 6xy squared, plus 1 multiplied by y cubed y cubed. Now you'll agree with me that the same answer is what you have on the other edge for Pascal's triangle. So both methods are actually useful for any house solutions that you want to take. Now I need to make you know something. When you have a question as 2x, say for instance, you could take this as your own assignment to work on this at the end of the day and probably send us answers back in the comment section. When you have a one as 2x minus y to the power of 3. Now please be noting, okay, that 2x is your a and minus y is your b. So you do not leave out the minus away from y. Minus y is your b. So in that case, whenever you see us putting y here, it has to be a minus y, minus y, minus y. You can try that on your own and drop us the answers in the comment section, alright? Or you could simply just email it to us. Yes, wonderful. We'd like to hear from you. Alright, so this is how we run Pascal's triangle and binomial theorem. Now there is one more thing I would like us to take on. But then before that, we will have to end this particular one here and then we'll finish up in the next video coming up. So keep watching and make sure you drop your answers.